Hello, I'm Nishi Ahuja. I am an Intel fellow. I have been driving power and thermal management solutions. In the last 2 years, I've been driving liquid cooling a lot, but prior to that, I worked a lot on energy efficiency, which closely ties to the carbon emission reduction. So I'll be talking a little bit of what you heard in the previous session on how to build this software stack, which includes reduction of carbon emission as well as a reduction of energy efficiency. But before I go in there, I'll cover a little bit about like what's going on in the industry, right? What we heard previously that the data center power consumption is going to rise because of the obvious reasons, because of the AI and the other workloads that are power hungry. And that will result into emitting a lot of carbon. And why am I saying that? If you look at the carbon emission, it's divided into two parts. One is operational carbon, and the second one is embodied carbon. Operational carbon is the carbon that is emitted by the server operation, and it's 90% of your total carbon that is emitted. And then the other one is embodied carbon. That is the carbon emitted by the server IT equipment manufacturing process as well as data center construction, which is 10%. I'm going to be focusing more on the operational side of things because that's 90%. So when we talk about taking care of carbon emission, you have to take care of the energy efficiency, reduction in power at the data center level, because that's closely tied to carbon emission. I may not go into the details of some of the metrics that you have already heard today. There was already a work group, SEMI already covered a lot of this, but I want to share what the challenges are today with some of these metrics. We heard PUE, power usage effectiveness. It is one of the oldest metrics that is being used in the industry. It is the total data center energy divided by IT energy, total IT energy. And the total data center energy includes both IT and non-IT, which includes the chillers, the HVACs, everything in that part. And the CU is a metrics that is being being driven by Green Grid, and it is the carbon dioxide of a total data center energy divided by total IT energy. Both of these have challenges if we move forward, right? Let's say if we reduce the total IT energy, it's not and make no changes to the non-IT energy, it's going to give you a poorer PUE, right? So what's the OCP doing, right? There is, you have heard previously, IUE as well as DCUE, right? There is a work stream happening here at OCP who is driving a new metrics. So what that is, that IIU is basically taking IT energy and dividing that with computational energy, that amount of useful work that is done by the system. So from an IT energy, you are taking out the losses from the power losses, the power that is consumed by the fans within the system, and thermal leakage. So that becomes your computational energy. So that, if we further calibrate that with PUE, that gives you data center usage effectiveness. And that is the metrics that OCP workstream is driving. I won't go into more of this, but I wanted to cover what the challenges are in today's world. Similar to that, there are challenges in the sustainable cloud, existing or native cloud computing stack. If you look at this stack today, you have the service layer, you have the cloud OS layer, and the hardware silicon layer. But it is missing a lot. It does not have sustainability as a key design, right? It lacks a comprehensive monitoring or managing capability where you can monitor the power efficiencies or carbon emission. It's lacking that. There is a disconnect between the DSIM and the orchestration layer. They are on two different protocols or topologies and architecture. That's what the lack. Their sustainability is not the priority in today's native cloud computing stack. So what the goal is moving forward is to basically start reducing energy consumption, that is the foremost thing. When you're reducing the energy efficiency or energy reduction in the data center, you're closely tying that to the carbon emission. Plus, sustainability should be the principle, it should be part of your principal design. You need to build a monitoring and managing capability, which is monitoring the carbon emission or the energy information or the power information. And then the optimization should be at each layer that we looked at in the previous slide. So let's look at what Intel is doing, right, in terms of building this complete monitoring and manageability framework, right, from sustainability point of view. In the previous session in the panel, we heard a lot about telemetry. So what this is saying is the first step to even build or monitor or create an automated data center which does all this is by exposing the right telemetry from your platforms. And this includes not only the power information, it includes your thermal, your performance, and your failure information. Once you have collected this information, you can now build intelligence. You can look at all the issues that are there, or bottlenecks, and optimize that. But before you start doing that, you will have to first define policies. And the policies have to be defined at every stage, not at just one level. So there are different layers. So at let's say at facility level, you could define policies on power budget of a rack, or cooling capability, or you could be defining at an energy level what the energy efficiency goals are, or carbon emission goals are. And then at the performance, the SLO of the workload. And then once you have this operational policies in place, then you want to take actions. You want to control, like based on what you're optimizing, you want to control. So you have to tie this to a control algorithm or a control objective. So that could be you're controlling the facility fans, or you're controlling the fans within the server to optimize for power, or you're controlling the silicon, we're talking the power management features like the power knobs like dynamic voltage frequency scaling, or like P states or C states. So, or you're tying it to an orchestration where you're doing some scheduling. So all in all, if you have to build this self-managing system that is managing and reducing your energy efficiency and carbon emission, you have to start with exposing the right telemetry and building upon that. So what are some of the things that Intel is doing in terms of the solutions that Intel is building? We have already built quite a bit in this area. There's one of them which is SLO, adaptive power scaling. What that is doing is that the constraint that we defined on the SLO, we are taking that. So for a given workload, if you have an SLO, based on that, you are dynamically scaling the frequency and the performance based on the demand of the workload. So that's what we are doing. Secondly, we are also dynamically doing power and performance management, or doing dynamically adjusting the P and C states based on some predictive models. If, let's say, we have a customer who has certain period of a day that the servers are not being used, so they want to put those servers in sleep states. So we will use this solution to put those in sleep states and wake them up prior to when they need those. So that's the dynamic PC state optimization. Power-aware scheduling is something also we have built. This is based on the power constraint. We can move workloads around. So let's say if we have a rack, we have over-provisioned the rack, but it started exceeding the budget. We want to not do a performance penalty. We move the workload to a different rack. So you can do that kind of power-aware scheduling. You can also move workloads based on the thermal and power events. So we are doing quite a bit of that. And then I think Brijesh stressed on this power capping stuff, which is group level power capping. We have built a very sophisticated way of doing that. If you look at some of our data center customers, their power utilization in the racks is like between 30 to 40 or maybe maximum 50%, right? They are over provisioning their racks for power. Now, what we are telling them, you could go to the extent, like to the maximum, to the power budget, but you have to have some mechanism in place that if it exceeds the budget. There are two mechanisms that we have built in. One is the hardware part of it. So if starts peaking, you can pass like the battery backups can take that extra power. Or if you don't want them, the software layers control picks in, which is like you start capping some of the workloads which are least critical, and then still maintained within the power budget. We are also doing some on-demand cooling. Today, if you look at the data centers, there is total disconnect between IT and facilities. The way the facility controls are done with physical sensors in the data centers, and they are very inefficient. You could be overcooling your data centers or undercooling, so which is big impact to your overall power. So what this does is you're taking the telemetry from the servers and using that to control the cooling in the data center. So all these capabilities that we have built, we are tying that to a manageability system, because in the previous slide you saw there is a disconnect between all these management systems. So you need a management interface plus a way that all these are exposed as standardized APIs. So we are also, there is a session by Mohan Kumar who is talking about exposing this as Redfish API. I know in today's session, we can't go into the detail, but I was giving you just a gist of what we are doing. Call to action, sustainability needs to be addressed at a solution level, not only at a silicon level, but it goes from silicon down to platform to data center and facility. So it has to be addressed at all layers to get your power reduction down as well as improve the carbon emission. We have to adopt sustainability in the design principles of our cloud computing stack, as well as come and engage with us on the OCP project, on the telemetry piece of it, and then the metrics piece. As well, if you're interested in any of the solution, send me a note. I can send you some of the papers that we have around this. With this, any questions? No questions.